Yeah, this guy's so fucking good. It's almost fucking pisses me off how good this guy is, honestly. Look at bro, 17 projects in a year. Are we like serious here? So he made this one last year. He made 13! Oh my god, bro. And he's like my age. So fuck this guy, bro. Fuck, you know. I know he doesn't like work a job, but bro, what the fuck? What the fuck? I know I can do better. He made 13. I need to make
Riz. Wrong
13.
picture? Riz.
I don't know how I'm gonna do it, honestly. I'm gonna do the lead code first, obviously. I have some, I've jotted some ideas that I wanna do. But fucking hell, bro. Fucking hell. Fuck you. Where is this, by the way? It's in South Africa, I think. Fuck you. You're so good. Why are you so good? Why are you so good? Oh my god. Fuck you for being good. Fuck you. You're so good. You're so fucking good, it makes me pissed off. Brother, let's look at oh my god, bro. Oh my god, this guy's cracked as hell. For fuck's sake. So yeah, he's like an independent web developer for like 6 years apparently, and he gets paid. Oh my god, I need money. Ugh. Lord help me. He's cracked motherfucker. So let me like get this straight. Um, this will do projects. Let me do another one for projects. How do I get as good as him? It's crazy how good he is. Should be illegal. It should be illegal for him to own a bank account. He's so good. Why you so good, bro? Why are you good like that? I'm gonna put some real ideas. Fuck, where's my playbook? I wanna build some Chrome extensions too. Fuck's sake. I wanna make a blue whale type front end, back end. It's in to do. And OBS for mobile. I think this one is going to be a little bit better for. I think it's streaming, OBS streaming for mobile. I think you should be able to stream and do everything with your mobile. I mean, you don't have to, but the good thing about it is, yeah, this is like, I don't think I'm gonna do this, but let's have this here. Let's do another one. Portrait artist. I don't have the issue live streaming app. Probably not. Yeah, I want to do a CVAT annotation app for mobile. I'm pretty sure they have like an audiobook. As Leonardo says, good artists they create, great artists they steal. So I'm gonna steal this bitch. I want to do this. I want to do this. It's gonna be a SaaS product. It's gonna be a project. I want to do this now. That's a good one. Okay, let's. I think I've done enough. 1, 2, 3, 4, 5, 6, 7, 8. I need 5 more. Hmm. What should I do? I think I should like look into some of the API stuff, some of the backend stuff, learn about it. I am gonna go to the some of the easier top triangle and finish them off. How am I gonna, bro? No one fucking watches me. That's crazy. Like, come on, guys. I gotta get like a lot of money. Come on, you gotta watch me now. You gotta watch me. I gotta make money, you guys. You gotta watch me. Fuck, how do I make good videos? I need to make good videos. So this is my life right now. And where is it? Paint. Can I use paint? So this is how my life is going right now. Ooh, my fucking shit just hurts. Oh, it's in a different level. So I can't draw with my. I have some AI math learned, some DSA on the side, slash, what is it called? System design. And I got YouTube. YouTube. So this I haven't mastered yet. I'm gonna get really good at it. This is fucking difficult. I want people to look at me. I need to create another account too. So for this one, I need to create another account. I need to. You know what? I'm gonna like do all of my. That's what I need to do, honestly. I think every project that I make, it should like kind of make my YouTubing easier, if you know what I mean. Like make some like Chrome extensions or some shit to make my YouTube blow up a little bit easy. That's what like everyone does too. Like AI, it could be in the corner, doesn't really matter. AI engineering and all of that. No, it is difficult, but I will like learn along the way. It doesn't like hold the forefront of what I need to be doing. But yeah, it's fucking difficult. Fucking difficult. What am I supposed to do?
Batch of hats. Who's this? Thank you for the big super chat. Are you stealing my stuff? Dude, are you kidding me? We are gonna fucking sue you. Are you serious? This guy's just like ripped my design and is selling it. We are going to sue you. Bro said, I stole your hats. Here's your cut. Dude, fuck you. We are gonna sue you.
Flatecom sent $200.
I'm real.
Nick, just passing along the revenue from our first batch of hats. Grateful for the motivation you've given us.
Batch of hats? Who's this? Thank you for the big super chat. Are you stealing my stuff? Dude, are you kidding me? We are
Akash, look, I love you. Akash, look,
What the fuck?
but we have to talk about it.
What the fuck? This guy is so cracked. It's almost like it's pissing me off, you know? Let's do system design basics. Yeah, fuck. I need to install all of the VS Code and shit VS Code. Figma. Bro, just fucking download it already, please. Don't. Don't make me angry. Don't make me angry, bro. You got mobile? What even is that? What the fuck am I gonna do in mobile? Don't make me angry, bro. Hey, don't make me angry. I don't need to do any solo projects. I just need to like work on a lot of open source projects. But still, it's just like fucking pissing me off. That's not the way to go about it, but I know. It still kind of pisses you off in like a different way. A guy being better than you, it genuinely pisses you off. I genuinely can't like fathom someone who's like as good as him exist, you know? It's like, how the fuck? Fuck you, mate. Fuck you. Oh my god. Open Figma. Why the fuck are you so good? I should be that good, you know? It is what it is. It is what it is. What can we do? What can the ant and the colonies do when the humans pour molten acid? Well, what can we do? Right? They're the rulers of the earth. So this is the BJJ app that I was doing. Unedited in 4 months. Oh my god, bro. 4 months. Fuck. I need to do something. Finish, please. With the BJJ, I think should I like finish the BJJ app? I think I should. I have the vision for it. So how did he do it? Not this fucking idiot. Oh my god, bro! I need to make so much. I have like so much thing that I'm like my attention is like so split. I think data structure is like the first thing that I need to like hyper focus and like get it done because I really need it. I think this, yeah, data structures and SD will be the first thing. I'll be working on some fucking projects next. I don't know what should I do. What should I do? I'm kind of lost. I think I need some open source contribution. Oh my god, bro, how do I do that? The fuck, bro? Why am I watching memes in the middle of something transformative? I don't know what should I be doing. What should a nigga do? Holy shit, bro. This guy, bro. Kill yourself, man. Fucking ruined my day. He actually ruined my day. Because he has like so many of these projects. I feel like I'm so behind.
University, a place we. I mean, steal. I steal your work.
I'm so behind. Fuck.
Now,
I'm so
before you
behind.
judge
Man.
me, let me remind you of a quote by one of the greatest artists of all time. Make something that look, which is understandable because, look at it. Designs is for most people.
Fuck. What do I do? What do? What do? Should I do video essays? I should do video essays. That'd be fun. He made 13, bro. It's crazy. I need that number. I'm chasing that number. I don't care. 1, 2, 3. We have like 8. 8. I need like 13 of these. It's crazy. I have like so much shit going on. It's almost like, fuck, I'm just ranting. Ranting. Okay, bro. I feel like I need to like, fuck's sake. Let's do some basics. System design basics. I want to see how YouTube is. Yeah. How is YouTube made? I've seen kind of this, but it's kind of difficult. How is YouTube made? YouTube, system design. I like YouTube. I wanna work in there eventually. I wanna see. I wanna get some ideas from YouTube. I'm trying to find that video. It's you need to adapt fastly too. That's crazy. Adapt, overcome, whatever the fuck they say. YouTube. Oh my god, system design. Let me just system design. This guy. Is this guy? I'm sure it's not, but whatever, bro. Whatever. Jordan has no life. System design in an hour.
Hi everyone, this is GKCS.
Hello everybody,
In today's
and
video,
welcome back to the channel. Today we'll be doing a quad combo video of 4 different services, which we're all going to build in one video because they're all pretty damn similar. So hopefully we can get through it within an hour. Hello everybody, and welcome back to the channel. Today we'll be doing a quad combo.
This why. This why you don't get no matches in Tinder. He takes all your matches, bro. Yeah. It is what it is. Game is game at the end of the day.
If you click
System design.
if you click Today we're
Nigga,
talking about
shut up, please. Shut up with the LARPing, man. It's too much LARPing. Too much LARPing. I hate LARPing.
Okay, and I see in the chat, we already have a question. We got our first question. I don't post names, but I do like to post the text just for people that are watching this like asynchronously. Our first question is, any tips for getting matches on Tinder? My pro tip is don't use Tinder. All right, so we are going to be doing the design for Tinder this week. For the resources, I haven't seen this in any books at least. I've seen a couple of other channels do that, but I don't really trust other YouTube channels a whole lot with their solutions. I've seen some that are like really botched. And I understand how hypocritical that is as a person that runs a YouTube channel myself. And I'll just say like, you know, I'm giving it my best shot. Requirements, recommend accounts to the user. You're going to recommend other people's profiles to the user. And then the user is going to swipe left or right to indicate whether they like the displayed account or not. If two users like each other, it's a match, and you should send them a notification. Any questions before we dive into the diagram for this? I see one question in the chat. All right. How do we define a match? It's when two users like each other. So both users have to swipe right on each other. Right means they like you. Left means they don't like you. And we're going to put that in quotes. It's the language of Tinder. I think most dating apps use the same functionality now, though. It is it on the basis of some similarity. Oh, like the recommendation. Okay, well, so there's a match versus a recommendation. So a match is when they both do actually like each other. The recommendation is going to be based on some kind of internal score, or it's you can use you'll have rankings of similarity score. You can use a inverted, so you'll have this bio that you have to fill out, and it'll have like words in it. You can like pick out these words that are specific, like if somebody's says that they're a computer science major, or if they're in nursing or something, or they like running, it could match people that are running by you split the bio into words, and then you can do this thing called IDF-TF. I'm going to write that. So IDF, TF, and that is it means inverse document frequency, term frequency. First, I should specify that there's the match aspect, and then there's the recommendation aspect, and the match aspect is what your first question is coming from, and then the recommendation part, which comes before the match, is the basis for recommending stuff. Pretty sure it also asks you what kind of. So I'm posting another thing from here. Yeah, so I mean, there's also that's filtering. So that's the filtering, which is age age. Well, it's not. So you're supposed to be at least 18 in order to use that, but you can also do an age bound, and you can say that I want somebody that's between the ages of 18 to 25. If you're like college aged, and then you can also do like if you're way older and you're on the app, you might do that. And then we have another question in the chat, and it was how long is a match valid for? Matches are, so on some apps they do actually have a timer on the match, and that if you don't reply within 40 hours of matching, then they like delete it. And that's in order to encourage engagement on the app and to actually reply and talk to people.
This guy's legit, I think. What is Redis? I think this guy. Why does he have so many subscribers and so little videos? Popular one? Bro, what the fuck? Hey, what the fuck is going on, bro? Oh, who the fuck is subscribing you? Blood. Who are you, Blood? I think people like kind of subscribe to him and don't really. Like, what the fuck is going on with you, bro? I think I'm gonna learn some system design and start like making apps, which in turn I'm gonna. I think that's like the best way to do it. Learn it side by side. Do do the thing with JavaScript maybe. Hmm. Something fishy. Something really fishy. I don't know.
People that you've matched with. But on Tinder, I don't think it does that, and so it's permanent. It's forever. Tinder doesn't throw out your matches like other apps, I believe. We're not going to do that in this problem. We got another question. Can users see a history of their matches as a list? Well, yeah. So there's that's in the chat section. It's so after you match, it goes into this list of all your matches that you're able to message, and so then that's where there's this less. That's where there's this part of this app that we're not going to focus on, or maybe we'll focus on it later on tonight. Is the chat app aspect. Is that you basically have this contacts list, and the contacts list is like all your matches. Or is it just a one-time notification? The matches list is kind of a chat app where all your contacts are your matches. Cool. Okay. Something like YouTube history where there's always this user. Yeah. Okay, I think we're kind of familiar with how this is going to work. So we can go ahead and kind of get started on that, is that we will have a client. We're going to have the browser. It's not actually a browser, it's an app. So it's going to be
Okay, browser app. Cool.
some client app. It's going to be the user in swiping mode. User in the swipe screen. So there's like screens, and there's like swipe screen, and that's going to be the focus of tonight. I'm going to specify that for out of scope is going to be the chat app aspect. We can cover that later tonight, but I really want to focus on the matching aspect, the recommendation and matching aspect. So again, there's the app. You got to get those from somewhere. We're going to have, we're going to need to store. It's a little bit easier if we go towards the like capture and we wind it back over to the recommendations aspect. Or we can even maybe talk about the, maybe be easiest if we start off with talking about the DB schema a little bit, which is of course going to become denormalized. So we're going to have a user table. Don't like that font. Going to be some kind of user table. So you'll have, let's go. Have a user ID. Say that's something like 1, 2, 3, 4. And then you'll have a name. I'm just going to use mine. My username. It's usually they just kind of show the first name. And then we're going to have, there'll be some kind of user details that you'll expand, like the bio. And then there's actually an internal score that Tinder uses for it's your attractiveness score. And so it actually does use something kind of like that to maybe it shows you at least a certain number of users that are above an attractiveness score, just so that you're not like, oh, I don't like any of these things that are getting recommended lately. I think it's also used for matching similarly attractive people. It kind of makes sense if you think about it, but there's like an internal attractiveness score that kind of figures out based on other users ranking you and assigns it to you. And then you're going to be so there's like the user table, and then you have like a one-to-N relationship with okay, I did it like this. Yeah, sweet. All right. So it's a one-to-N relationship of one record to another one for the likes. So we're gonna say one-to-N relationship for likes if the mutual like that goes into a match. And so you can even have that as, so you would store these through a join table. We're gonna have a join table. So we're gonna call this the swipe match table. You'll have the user ID of the one that's like viewing it, 1, 2, 3, 4. And then you'll have the, we're just gonna call it other ID. You'll have something like 3470. And I don't know if you actually need this, but you can have like a link ID to just, you don't need this. I think it would be useful for the chat aspect later on is a link ID to be associated with each pair, but this would kind of work as a primary key. You're going to store each, in my opinion, you're going to store each record for each like separately, because you're also going to have this enum called swipe, and it's going to be like or dislike, depending on if you right swipe or left swipe. And so if I like an account, you also need the other account to also like, and so this one would be the other account. You got to flip it, and they would also have to like in order for it to become a match. And so we should also have a isMatch flag, and that's going to result in some duplicated information. I think that's okay. When you're going with NoSQL databases, you're usually going to have some duplication of information just to make the reads a little bit faster, is that you have to do some kind of denormalization a little bit. But until this second person likes me back, so until this record is also written, isMatch is going to be set to false, and then as soon as the second one is written for them liking me back, be set to true. And we'll show how that's going to work later on. I'm going to set it up possibly as a DB trigger. There's a couple of different options for how to do it. I see a question in the chat. I'll go ahead and
Doubly distributed linked list. What the fuck? Oh, fuck does that even mean?
welcome to Systems Design Fight Club. Answer it. Why is swipe match a different table?
Isn't it kind of crazy when it comes to like senior design and shit like that? Like the views is like 7,000 people. Goes on to like show you like the people that don't really like watch it that much. Language fundamentals, yeah. That's 10%. Okay, let's write it down. What we need. I need I need 5 hours of DSA, 2 hours of system design, like videos. Behavioral, how the fuck? What even is behavioral? What even is that? Like, I need to get a job right now, bro.
Today we're going to be solving the distributed linked list problem. It's taken from somebody's real Google system design interview experience. We did manage to get some nice scale problems for this number. Well, so if you have on the same table as just a list, well, so we might do that in order to denormalize it. If you have if you have a lot of records, though, I think it makes sense to federate it out and just leave it separated as another table. It made a bit more sense as a separate table when I was looking at it with how you set up the backend services. Let's go ahead and maybe explore the diagram a little bit more. Is that so you have this, and you would have the recommendations coming in, and then you would have the swipe results coming out. So this one would be the recommendation service. Recommendation service. Sure, let's just go ahead and leave that as one big word. And then you're going to have the swipe capture service. Should be over here. So you'll have recommended accounts will be coming in over here. And when you like or dislike account, it could come out over here. And then, so you're asking if you could just go ahead and leave it merged as one big table. In this database, I think it makes more sense to decouple it because I think you're going to have the users table should be read heavy. If you have just that on its own, it's read heavy, while this one's write heavy. And so there's different optimizations you can make depending on whether table is read heavy or write heavy. So splitting them out, I think, makes sense just for allowing some optimizations to occur. That is an interesting idea, though, is that we could possibly have all the lists, all the matches as one big list. Well, so if you're storing all the likes, though, so some people like really go through like dozens of accounts in one day. And so then if you use it for like a month, that's like hundreds of preferences that you're putting into the swipe table. And so then if you had your likes stored over here, you'd have a list of hundreds of accounts. And then if you're trying to look up your matches, that would be really inefficient. And so I guess that would you would definitely like have like hundreds of likes. And then you would have to find the likes going both ways in order to find the matches, and that would be really inefficient if you don't split it out to that separate table. So you should definitely be separating that out into different table. Otherwise, it would be really inefficient for finding the matches. Yeah.
So you have recommendation service, client app, users, screen swipe,
Okay.
swipe.
So I was saying that this should probably be split out into a user table and a swipe match table. So we're gonna have the user data store, and then we'll have the swipe match data store over here. Okay, and so you'll be doing, well, okay, there's recommendations. That's different. So recommendations is different. You're going to need some kind of model that's generating recommendations for that. So that is going to come off of a data model. Some kind of data model is going to be doing that. Let's go ahead and explore the diagram a little bit more. Let's move this on up over here. Okay, so there's the user data store. Let's do this. So when you have a recommendation that's made and you're pulling it up, you're going to be pulling up their pictures and stuff like that. And that should actually maybe, so you don't want to store pictures in the user data store. You would have a CDN actually for, you should probably store their pictures on a CDN. So let's have a thing for that. CDN of profile pics. And the bio can also possibly be put on the CDN because it's going to be a blob of like 500 or more characters. You might have a limit of like 1,000. You can even just store that as like a JSON blob of just profile details that just get rendered up on this thing. You would also have the user data store for, that'd be relevant for like the filtering stuff for the recommendations. So that and bio. But you don't really need to have the bio stored directly in recommendations that are being made. So you have a recommendation coming in, and then off the response, off of that, you're going to fetch the profile pictures from the CDN, and then you're going to right swipe or left swipe. That gets recorded over here. You ping this service, and it's going to do a write over here to the swipe match data store, which has this table over there. Okay, and then based on your preferences for an account, there'll be some kind of other thing that's doing analytics to come up with some recommendations. I think you would have, there's kind of like a couple of different ways to do this. One is that you have a list of recommendations generated every single day. So I'm going to kind of iterate on that idea, is that you'd have this nightly batch job that looks at your preferences and generates some swipe recommendations for the next day. So there's actually a limit to how many swipes you can do in a single day on Tinder. It might be like 100. Other apps might cap it down at like 3 or 5. Like there's this one called Coffee Meets Bagels. I think only gives you 3 or 5 swipes per day, which forces you to be a little bit more open-minded about who you're getting matched with and to actually look at it and think about it a little bit harder. Anyways, we'll have a recommendation data store that we're going to queue up some options on. And they're going to be getting pulled into the recommendation service. And I see we got another question in the chat. Can use something like a Siamese neural network, which can generate a similarity between 2 given profiles, and we can pre-cache those at some cadence. Usually neural networks are used for classification. I think we are doing a classification approach. Yeah, we are going to be doing classification here instead of clustering, I think. But swipe profile should not be recommendation. Well, so yeah, that's something that is in the filtering for how you. Oh, come on now. Is it freezing up or did it not properly copy this? Well, so yeah, when we're generating the recommendations, it should not be pulling stuff that's already swiped. So we have that, and then we're actually going to have this copied over to an analytics area. You don't want to do analytics on an OLTP database. This is an OLTP database. This one is as well. So we're going to want to do change data capture with maybe a DB trigger. Another approach is a stream. But Steve from the channel Life Engineered, who's a principal engineer, says DB triggers work just fine. But this is going to be like a data warehouse, or it could be a lab database, just something for analytics. And then we're going to have this set of workers that runs once a night. We're going to call it workers. And you're going to have the data model will deployed to the worker machines. You can do A/B testing. You should be doing A/B testing, but there's you have like these machines that run a nightly batch job, and you can have which model is deployed to your set of machines, or which one you're running on a set of accounts. The copy of your model, or which edition or version of it, can be stored on the recommendations records that you're going to be putting over here. But the worker is going to pull in it's data from the swipe data store copied over here. It's going to pull in that data. It's going to use that for generating a set of recommendations to so it's going to put out some rankings of accounts to the recommendations. It's going to rank some stuff, and whatever it ranks high, they'll have over here queued up for swiping on the next day. Okay, so the data model will be over here. You're going to use a classification model, and so over here you'll have recommendations. Let's maybe talk about what that'll look like a little bit. You'll have a schema. It's the recommendation table. And so who are you recommending it for? That'll be the user ID. So that's recommending for me. User ID is that. And then the rec ID of the other account, let's say it's 3470. So it's recommending this account, and it'll have the score of something like 9, or let's say 0.91. Usually you have you can have a score ranging from 0 to 1. It's the strength of that record in the output of the classifier when the worker is looking at a specific account under your preference, and it would be a recommendation score ranging between 0 and 1 in the output, and it'll spit it out over here. And then it's going to be pulling in the accounts that have highest score. And of course, you'd be able to do your filtering over here in the recommendations. So you can actually change your filters the next day as you're going through the recommendations of like your age preference and the location preference. That's another thing you can filter by, is that there's age filter.
What the fuck am I even looking at? I don't even know what is going on, bro.
And then there's also location filtering. It's another thing. And so you'll have these recommendations, and I guess you could even inline the account data directly into it. So then that would be like the rec age. So let's say they're 22 years old. You can have their location, which is lat longe, so like negative 42.37 degrees, comma 17.45 degrees. And so you can have this in something like Elasticsearch, which has a quad tree for location filtering area. And then you would just sort it by this, and then you can do where clauses over there. I was indicating that there's like 0.0 to 1.0 interval on the score part. And then you can do filtering on top of that as you're pulling the recommendations. Okay, I see more questions coming in. Can use a Bloom filter for this. Well, that's a feature of your database itself. You shouldn't be memorizing algorithms. But sets has been viewed or not viewed. You could, so you're probably thinking like for pulling in whether or not a thing was met. Well, so this is for like existence of a record. This is like a uniqueness thing. Like, does the record exist or not? That's what Bloom filters help with speeding up. Well, in our case, it's like given my user ID.
He's dealing with some retards, bro. Retards in the chat. So much retards in the chat.
Have I ever looked at them before? And you would maybe use a pair of user ID, rec ID, but this is the recommendation table, so that's not relevant here. Yeah, that's not relevant here. And the recommendation of an account can actually increase or decrease depending on the day. Oh, I forgot, this should also have like a date stamp. It should have like the day of the recommendation. So an account like on the next day, so right now it's like 2023, 01, 28 is today. And then like it could reevaluate that account the next day and actually recommend it even higher. And then if I didn't get around to that record in the previous day, it elevate it in the rankings the next day possibly. So then on the 29th, it might actually have a higher score or a lower score, which means that'd be ranked higher or lower in my likelihood to see that account. Okay, I believe location plays an important factor. Well, so that's why location can be inlined into. That's why location can be inlined into the recommendations table. Okay, recommendation could be an hourly job based on location. Well, so yeah, you could the batch job can be. This could run daily or hourly. It doesn't really matter. And ideally, it should actually be continuously run, and you would actually do reinforcement learning. You'd be doing the, what's it called, multi-arms bandit approach. I think Tinder might actually do multi-arms bandit. A lot of recommendation engines actually do multi-arms bandit. So
multi-arms bandit approach. explain in a short? Why don't you like explain that in a shots?
The multi-armed bandit problem allows us to study the balance between exploration and exploitation in reinforcement learning. Imagine a slot machine with multiple levers, each corresponding to an action that yields a reward drawn from an unknown probability distribution. Your goal is to maximize cumulative rewards over a sequence of choices. At each step, you pick an action and receive a reward based on its distribution. The challenge lies in estimating which action offers the highest expected reward while ensuring you don't miss out on potentially better alternatives. At each time step, the action with the highest estimated value is the greedy action. However, always choosing greedy actions risks missing out on better rewards. This leads to the exploration-exploitation trade-off. Exploitation focuses on maximizing immediate rewards by selecting the greedy action, while exploration involves trying other actions to gather information and improve long-term outcomes. Balancing these strategies is the essence of reinforcement learning. The multi-armed bandit problem.
Okay.
The YouTube homepage feed actually does multi-arms bandit, and so you could actually bring it. Could even be continuous and use multi-arms bandit. But when you're doing it continuous, I don't know if you'd really be using a data store if you would just have it being hit directly. I don't know how things look when you go with a what's it called, semi-supervised approach. Shoot, I forgot the name of that one between supervised and unsupervised learning. Reinforcement learning. That's reinforcement learning. There, I'm going to write it down so I don't forget it again. But that's from reinforcement learning. And I'm less familiar with how machine learning models will look with reinforcement learning, but with classification, which is the one I'm currently going with, you might want to just have it cached output because the model might be kind of expensive to run. Expensive meaning slow, and so you might want to just have it there. You need to cache a load balancer. I'm just going to post these. I always forget to use a load balancer. Yeah, I always forget to use a load balancer. And sharding. Yeah, I can talk about what partitioning key I can use. But yeah, I like talking about what type of partitioning key to use. So yeah, you could use a load balancer in front of there. Let's just use this component. And then let's use like yellow. It's a good color for this. Maybe I'll just use green. Sure. Yeah, I always forget to use load balancers. You can even use that on the swipes. The swipes should be occurring at the same rate as, well, actually, you can go ahead and do, you can get a response, a list of recommendations from the recommendation service in the background. And then that would maybe make this a lot lower with TPS. And so the TPS on this could actually be higher. But if anything's going to need a load balancer, it would probably be the swipe capture service. I totally forget about load balancers a ton, though. With AWS, you just use an elastic load balancer, just kind of throw it out there. Yeah, okay. Partitioning keys. Yeah, okay. I have the recommendation store. We have the swipe store. Let's go ahead and move this up a little bit. And then I'm going to make a copy of this. And we'll talk about the keys for it. Here's the swipe match store. Your primary key would consist of both of these.